academy as a whole. Sorry for that. So we have an academy where we do different training programs, but why we do it? So this is very clearly explained in this particular report from data.org. It's a workforce wanted report, which was published in 2022 in partnership with many organizations. So the report have two key points that came to our attention. So first is there is an opportunity to shape and develop 3.5 million data professionals focused on social impact in developing countries over the next 10 years. So something is happening in my screen. So whoever is playing with the mouse, please do not. I can see some drawings. Thanks. So we have this particular insight that came to our attention is that there is a huge demand for data professionals in the social impact sector in the next 10 years. But there is also a big gap. So 50% of social impact organizations are not fully aware of the ways data can impact their work. So these were the two key things that caught our attention. And there were 4 pathways developed to expand this knowledge base and to have more people joining the workforce in social impact sector. So first is new talent. So we want to attract new talent to go into this field. And this we do through our master's program, PhD research programs. Recently, we launched an Analytics for a Better World master course at University of Amsterdam. We do similar programs in other institutes as well. So this is how we try to get new talent more aware that in social impact sector also there are brilliant use cases that they can work on. Then existing social sector talent, that is what we try to do with academies such as this. So we want to upskill and train the next generation of social sector talent and to make them aware of what are the possibilities with data science. The goal of this fellowship is not to make all of you a trained Python developer or a Power BI expert, but as Professor Dick says, we want to teach you the art of feasible. So what exactly is possible with data science? What kind of use cases can you do? And what kind of tools do you need in your belt to implement this? So our goal is not to, like I said, create experts in 8 weeks, which is not possible at all, but to give that feeling of what kind of use cases can be worked on, what kind of projects can I tailor, what kind of skill sets I need within the team. We also have a lot of transitional talent. So existing data professionals who will be brought into the social sector, which is we try to do through our private sector collaborations. So in your journey, you will meet a lot of mentors who will be helping you in your projects, training the trainers in the program. So they are actually transitional talent. So they are coming from a different sector altogether, but helping you in the data science journey. And this is one of the main thing, leadership. So leaders and senior executives should also acquire new capabilities to support data science talent within the organization. And we do this through our executive education program, which we will be launching next year. So this particular fellowship is for more hands-on practitioners, but we will be launching another course for the leadership executive program in the coming year. This is how we started the cohort last year. So we had 43 fellows and they were supported by a group of mentors and trainers from our private and public sector partnerships through universities, and they trained them for 8 weeks. And we started not just learning about data science, but we started creating a community of practice. We did a lot of networking. I met some of them during my trip to Kenya. And we are already involved in a lot of projects with them as well. So we are continuing the relationship, and the fellowship is not the end, but it's just the beginning of the journey. So we are doing a lot of continue to work with our cohort 1. Now it's actually time to welcome the chief guest of today, which is you fellows, the second cohort. And it's a really proud moment for us as a team because we went from 43 to more than 100 fellows. So it's also a learning for us that we are scaling. It's more than double what we had last year. But so far, so good. And we hope with all your cooperation, all your support, we both are going to learn a lot in this journey. And you are not going to be alone in this journey. I will take you through some of the support that we will be giving you. But just to give you a flavor, we have more than 100 fellows from more than 55 organizations from around the globe. So it's actually a great way to show that we are not just coming from one particular geographic location, not tailored for one organization, but it's really a huge group of people coming together. And the goal is not just that we train you, but it's also about peer-to-peer learning. What can you learn from each other? What kind of challenges that as a whole institutions face, and my challenge might already be solved in another non-profit, because there is a huge potential for peer-to-peer learning across boundaries, across use cases, across sectors. So that's exactly what we hope we can achieve by this. And in this journey, we are here now, which is the launch event. We'll go through a lot of coursework together. So we'll do a lot of fundamentals, getting started. We'll also do a lot of hands-on work, but then we'll start with our project phase. We'll identify a challenge together. So in week 2 of your fellowship, we will ask you to create a draft project proposal. So what would you like to work on it? What would you like to work in part of your project? What kind of challenges would you like to address? Then we will connect you with a mentor and a peer review group. So the peer review group will be people who are facing similar challenges or using similar tools, techniques. For example, if your goal is to build a Power BI or a Tableau or data storytelling visualization, we will put you in a peer group that's also focusing on visualization. Whereas if you want to build a geospatial model, we'll put you in a peer group who is also dealing with modeling geospatial data. And we are going to also have, can you please mute? Thanks. We'll also put together, there will be checkpoints where all these different groups and clusters come together. So you will have your peer review meetings, but also touch points and checkpoints. We'll then implement the project. You have 4 weeks. We say 3 weeks full work, and then you have 1 more week of additional support, mentoring, maybe mentor matching. So you will have time to implement a POC. So we are not expecting a full-fledged solution in 4 weeks of course, but a proof of concept of what can be possible. And then we'll do the final closing ceremony, and we'll have a presentation. And I want to mention that this is just the beginning of the journey. So you present your project. That doesn't mean that our relationship is over. We hope that we can get started from that point and start a network of collaboration starting from there. So it's just the beginning, like I said. You will not be alone in this journey. So you'll be supported by our trainers from different organizations. We also have a group of mentors who will be supporting the peer review groups in their project work, also coming from different, they all come from different type of data science backgrounds, data engineering, data scientist, data analyst. We have different sectors like automobile, logistics, energy, climate. So we have mentors and trainers from different sectors and different skills. But mainly, you will see these 2 rock stars of Academy, Kate, which she already spoke in the beginning, and Martha. They are kind of the 2 people who have actually made this possible to scale, because last year, like I said, we had 43. From there, we are now at 100. And these 2 are our team rock stars who have made this possible. And they will be there throughout this journey to help and support you, of course, together with the rest of the ABW team. They will reach out to us if we need to intervene, you need any additional help. But I also would like to take this opportunity to appreciate both Martha and Kate to have brought this into reality from draft ideas and project proposals and stories that we try to come up with to make this a success. With this, before I hand over to Robert, who is going to inspire you to get started in this journey, I want to ask you a simple question. What are you most excited about this fellowship, from what you have seen so far, from what you have heard today, or what are you most looking forward to about this fellowship? Either you can scan this QR code in your phone, or you can also use the link that Martha have just posted in the Slack group. So you can either use the phone to scan it, or you can use the link to start giving me your replies.
Parvati, should we be able to see a QR code?
Yes, here.
We only see the PowerPoint right now.
Okay, I see some results, but I'm going to stop and then start sharing again. Do you see it?
Yeah. Great.
Okay.
Thanks.
Thanks, Kate. So peer learning, awesome collaboration, mentor, networking, project, data visualization. I see a lot of you are typing, so that's good. Applying, yes, learn new technical skills. I'm so happy to see a lot of non-technical keywords highlighted more, because yes, you can, it is about learning technical skills, but yeah, I really love to see this, like making an impact and networking and peer learning, because that's exactly our goal as well with this initiative, is to bring people together to be able to collaborate, network, learn from each other, and also use this as a platform to build new relationships, not just with us, but with each other and organizations coming together. With this, I'll pass over to Robert, who is our managing director, to say a few words and hopefully inspiring you to get started with all of these goals. Thank you so much.
Thanks, Parvati, for the lovely welcome, and I want to welcome all the fellows. I guess inspiring you is maybe a bit much to cover, especially given Dick and Dimitris coming after me and sharing all very amazing work that they have been doing, and very impactful research and projects. So don't get your hopes up. I won't inspire you, I think, too much, but I'm very sure that Dick and Dimitris will after me. So I'm just very happy to welcome you. I'm very happy to see that the team from ABW pulled this off. 100 people who subscribed, doubled, more than doubled the amount of last year. So I knew when I asked them to scale this up that it was going to be a challenge, but I see we managed, and I'm very proud of that. So we really believe with Analytics for a Better World that we can drive positive change by applying analytics and contributing to the sustainable development goals. But we also know that by ourselves and by our also our small team, we can only do so much. So this fellowship is for us a really important thing, to share the knowledge that we have, to share the skills that are necessary for this, and also, well, inspire you to become a practitioner and apply these skills yourselves on the SCG, and also work together with us to drive our mission forward. So I hope that you will have a very nice learning experience in the coming weeks. And I am very much looking forward to see all your projects in about 8 weeks. I had to miss it last year, but this time I've marked it in my calendar to be present at this closure session, because I heard amazing stories of that session last year. I just want to give 3 very small tips for you to make the most out of this program. Is that, well, learning data science you cannot really do by just attending courses and watching people speak. So it is really important that you get your hands dirty, work with data, work with your stakeholders. Don't be afraid to make mistakes. Obviously, we are here to help you, and I think that's all part of this learning process. Please also feel free and encouraged to work with your peers and with your mentors in this process. They are also here for you. So don't work in isolation, but work together, because we believe that then learning goes a lot faster. And I see that already a lot of people have their camera on and are also actively engaging in the slide that Parvati just shared. But please keep that up for the rest of the program. This will really help our trainers also provide you with the best learning experience and the best content. And this will also help you in your own learning, the value that you get from this course. That's it from me. I want to hand over to Dick, and I'm looking forward to see your everything that you learned and all the amazing projects that you will be working on in about 8 weeks. So good luck to you all.
Thanks a lot, Robert. I would like to share my screen. Let me see. Okay. Great. Can you see my my slides? Perfect. Okay. So hello, everybody. It is also for me really almost emotional to see you here. You know, this is what Bhavat already said, one of the biggest and most important events. So I'm really happy to see all of you here. So my name is Dick den Hertog. I am Professor Analytics in Amsterdam, the University of Amsterdam. And I'm also a Science to Impact Director of Analytics for a Better World. And in the past, I did a lot of analytics projects for all kinds of applications that are in, let us say, contributing to the Sustainable Development Goals. And today, I would like to inspire you by just describing some of those projects and to show you the impact that data can have on better decision making. So the title of my talk is Optimization for a Better World, and later it will become clear why I have chosen for this title. Okay, so before I start, I would like, because I'm a professor, so I would like to already give you some insights in what is analytics. So analytics is about using data and also algorithms to get better insights, and finally also to have a better decision making. So data is, of course, a very important role in it. And nowadays, analytics, data analytics, and business analytics is really very important and used a lot. And that's because of a number of reasons, I think. So first of all, of course, the amount of data that is available nowadays is huge. Secondly, the storage of data is becoming very cheap over the years. We have better methods, algorithms now available, and also the computer power has increased a lot. Okay, so we distinguish 4 types of analytics. So the first type is, and then I will use my laser pointer. The first type is descriptive analytics. So in descriptive analytics, we in fact use data to describe what's going on or what happened. And the second category is diagnostic analytics, where we use data to understand why it happened, why it is happening. And the third category is predictive analytics, where we use data to predict what will happen in the future. So typically, so for this, we have, let us say, the machine learning type methods. And here, this is more, let us say, the classical statistical methods that are used. And then finally, the fourth category is prescriptive analytics. And there we go one step further. There we also use data to determine what is the best action, what is the best to do. And that's also called optimization. So the title of my talk was Optimization for a Better World. So my talk will be about this type of applications where we use data to optimize, to try to get the best actions. This is a figure by Gartner, and on the horizontal axis we have the difficulty. So you see it's also the most difficult part. So I start already with the most difficult part. And on the vertical axis we have the value. So especially I think that also in these prescriptive analytics applications, there's a lot of value. And I think Dimitri will talk more about machine learning and predictive analytics applications. Okay, so I will start with the first application, and that is an application that we did in Timor-Leste. So it's about optimization of hospital locations. So in fact, Timor-Leste is a country close to Indonesia. It became independent in 2002, and the World Bank, we did it together with the World Bank, is in fact helping them with loans, with money, to improve the infrastructure. And one of the things is in fact improving healthcare facilities. So the idea there is that in fact improve the infrastructure with respect to healthcare, especially hospitals, such that people can, for example, reach a facility, an hospital, within 5 kilometers. So good access to healthcare is very important because it's too far away, then people will not use it. So this is a very important goal. So here you see the existing locations of the hospitals. And the first question that in fact also the World Bank was asking us is, okay, so given this current situation, which percentage of the population do have access to a hospital within 5 kilometers, for example? And given that, how many more hospitals should we add and where, such that we have a coverage of, let us say, 95% of the people that can reach such a hospital within 5 kilometers? And so the first question was more about, let us say, descriptive analytics. What is the current situation? And the last question, how to improve it? What is the best action? How many hospitals should be added? That's more a prescriptive analytics question, an optimization question. Okay, so that's what he did for them. And so with respect to the optimization part, so for example, if the question is, suppose that you would like to add 30 or 20 hospitals, and what are the best locations for it, such that the maximum amount of people can access a hospital within 5 kilometers? That's already a tricky and a very difficult question, because if we just enumerate all possibilities and then use the computer to choose the best one, that will take thousands or millions of years. So therefore, we need very smart algorithms, optimization algorithms, to find the needle in the haystack, to find the best solution among the huge number of solutions. So that's what we did. So we developed a linear optimization model for it. And we can, for example, this is one of the results, just for one district to keep it visible. This one district, Mera, and this is the current situation. So the green ones here are the current hospitals. The green dots are, in fact, the clusters of households that are within 5 kilometer distance, walking distance, and the red ones are not within 5 kilometer distance. So it appeared that 63% of the households are within 5 kilometer distance. And then the next question is, how can we improve it? So here you see the placement of the locations of 10 extra locations, the blue ones. And by doing that in an optimal way, we can get an improvement from 63 to 81% of the people that can reach a hospital within 5 kilometers. Of course, we did it also on the national level. And we also constructed this type of curves. On the horizontal axis, we have the total number of hospitals. On the vertical axis, we have the coverage, so the percentage of the people that can reach a hospital within, let's say, 5 kilometers. So here you see, for example, in the current situation, there were 139 facilities with a coverage of 63%. And if we add more of them in an optimal way, so in each dot here, it's an optimization run, you can get this curve. So then, for example, for 95%, you need something like in total 180 hospitals. And when there is greenfield, so suppose that you would start from scratch, so no hospitals, then in fact, at the 95%, you already get much earlier. And in fact, with the 139, that's the current number. If you would do it optimally, then you would get a coverage of more than 99%. So this type of insights, of optimal decisions, gives a lot of insight for those people who want to spend their money the best as possible. So that was the first project, but we discovered that there were many other questions, also by other NGOs and by other countries. So we did a similar project for stroke centers in Vietnam. So strokes is in fact the #1 cause of death in Vietnam. So it's important that people can reach a stroke center in a short time. So what you also did is optimize the locations of new stroke centers such that the access to the stroke centers is optimized as much as possible. We also extended that and looked at the capacity, the number of beds, because we would like to avoid that if a patient comes in that there are no beds available. So also there, the question about enough capacity is a very important one. By the way, so you can imagine that for this type of questions, a lot of data is needed. Data about the population, data about the roads, because we'd like to calculate the distances. So a lot of data is needed to answer those questions. Another application that Parvati did in Nepal, that was about locations of COVID test centers, and it was together with the World Health Organization. A similar project that we did are doing in Kenya with AMREF about with mobile clinics for vaccination. Also, another project is in Sudan, boreholes or water wells in Sudan, together with the Red Cross. In fact, maybe also nice to tell you that this project came out of the previous fellowship in 2022. So one of the participants had this as their final project, and we extended that, and together with her, we did this project. A totally other project where we also used optimization, where we used data to, in fact, to get better plans, to optimize plans, was for a small social enterprise in the Netherlands, and they are developing an app for small farmers in Africa and Asia. So it's called the Feed Calculator, and that's an app, and that is for free. You can get it for free, and that is now used by thousands of farmers to optimize the feed for their cattle. So what they do is the following: they just say, "Well, I have, let us say, 200 chicken, and I would like to feed them. So I've available a number of possible ingredients, cassava, maize, and so on. And I know what it costs per kilogram. And then I would like to optimize such that the cost is minimized, and also such that all kinds of nutritional requirements, so much protein, so much vitamin, so much, and so on, are satisfied." Also for that, optimization is used, prescriptive analytics is used, and that's what we developed. So that's inside the app. So inside the app is an algorithm, linear optimization, that is used to for the farmer to, in fact, generate an optimal plan. So this is now used by thousands of farmers, a big impact because they now say, well, we can make more profits. And because of that, now also our children can go to school. So that's another example of it. Another example is for the United Nations humanitarian response depots. And that's about the location. So where the UNHRD, they have depots where all kinds of material can be stored, such that if there is a disaster somewhere, an earthquake or a flood or you name it, such that we can use this material as soon as possible. So the idea is to have it as close as possible to the disasters. Of course, we don't know where the disasters will take place, but we do have a database of previous disasters in the last hundreds of years. We use that information also to construct optimal locations for their depots, such that the costs, but also the response speed is optimized. You can imagine that a lot of data about disasters in the past, data about distances, road networks, but also on the sea and via the air. So a lot of data is used here. I think looking at the time, I skip that one and I go to this one. This is also a project, a totally different project. And I think that is maybe difficult to grasp already now, but certainly I think that later during the course, during the program, all these methods for both predictive, prescriptive, and also descriptive analytics will be treated. And then you will also see that the principles and the basic methods of optimization are so generic that you can apply it to many different applications. To say, for hospital locations in Timor-Leste, to an optimal diet for cattle, to this example where we use it to optimize the plastic removal from the oceans. So this is a project for the ocean cleanup. There's a Dutch organization that tries to remove the plastic from the oceans. And in fact, there are 5 hotspots in the world, 5 hotspots where, due to the current, the plastic is more or less collected, although those hotspots are very big. And so, for example, one of the hotspots is it's called the GPPP, Great Pacific Garbage Patch, and the size of that patch is 3 times France. So that's really a big area. And also, if you look at that such a patch, then the plastic density is not homogeneous. So that means it is in some locations there's more plastic than in other locations. And so they do have some predictions about the plastic density in those hotspots. And then the question is how to steer this system. So this is the system they use. So this is, now they have a system where this is 2 kilometers. And so in fact, they are sailing in that direction with a very slow speed, and then the plastic is collected in the retention zone here, and that is emptied when it is full. So then the question is how to steer this system, in which directions, such that maximal amount of plastic is collected in a certain amount of time. So it's like a Pac-Man game. Maybe you know that that game, Pac-Man game from the past. Maybe I'm too old that I know that game and you don't. But so that's the question. So what we developed here were optimization algorithms, prescriptive analytics, using a lot of data, of course, data about the predictions of the plastic, also how it's changed over time, predictions about the weather, the waves, the height of the waves, and so on. All that data is used to find an optimal route for this system, and then each morning the new direction and the new route is then sent to the captain of the boat. And so we did that, and you know, here you see, so this is in fact a part of the ocean in kilometers or in miles, I forgot. And so here it starts, the system starts, and colors indicate the plastic density. So the lighter, the higher the density. So green is low density and red is high density. And so this is the optimal path. So you see it goes over the light parts. And that's found automatically by this algorithm. And due to this method, they can now, in fact, what they, if you compare that with their current methodology, in the winter, it collects 90% more plastic, and in the summer, 50%. And so the reason for that is that in the winter, there are really often high waves. So our method is really able to avoid those situations a lot. Okay, so this is a work that we did together with some researchers from LBS, Jean Paufilet and Baisi Song. Okay, so these were just some examples. Again, we have descriptive analytics, diagnostic analytics, predictive analytics, prescriptive analytics, and I gave you some examples of prescriptive analytics optimization, and certainly in the program there are many, much more time will be spent on optimization algorithms, and after that you are also able to do this type of projects, like the application for the boreholes in Sudan that one of the participants did last year. Thank you very much.
Thank you, Dick. That was wonderful. Then we will hand it over to Dimitris.
Good morning, good afternoon for many of you. My name is Dimitris Bertsimas. I'm a professor at MIT, a close colleague of Dick's. We finished a book together and multiple papers. And we teach a class of analytics for a better world at MIT every spring to about 50 undergraduate students. Let me share my screen. Hopefully I'll find it. So my intention, if that's okay, is to present some applications of analytics that I have been involved. And quite a bit of my work is about healthcare and medicine. It is philosophically starts with the belief that data in electronic form in medical applications are now available, and this gives the opportunity to utilize machine learning and optimization methods, predictive and prescriptive analytics, to improve outcomes for patients as well as the overall care that of the system. So my story starts with the largest hospital system in the United States, Hartford Healthcare. It has about 7 hospitals, approximately 2,500 beds. It's a representative of a typical US hospital network. It's the largest hospital system in Connecticut. Connecticut is a state near New York. And over the last 7-8 years, we have been working very closely with hospital leadership, doctors, nurses, bed managers, and so forth. We have weekly meetings and so forth. In fact, today, I give a large presentation about several hundreds of practitioners. in the hospital. So what we have developed, we have developed many things, and I would like to discuss. So on a daily basis, patients have, of course, electronic records that accumulate every day. They have new tests, they have more exams, doctors write notes, they have radiology reports, they have scans, and every day in the morning, we receive this data for all patients, or about 2,500 patients in the hospital. And what we try to predict is the length of stay. Namely, we are basically saying, is this person leaving tomorrow or leaving the next day? And this is material because keeping people, I mean, hospitals are, you can catch infections and so forth. It's also good for the hospital to increase the throughput. We have our work using predictive analytics. We utilize machine learning for that, has resulted in a decrease of the length of stay in the last 2 years that we use the system, from about 5.7 days to 4.9 days, almost a day in decrease. We also predict mortality. For example, the method selects for every patient, also outlines the probability of mortality for the patient. And if the mortality probability increases even so little, let's say from 3% to 5%, humans cannot observe it, but machines can. And what we have observed is, over time, we have, in fact, detected people who were undetected by the humans that were getting worse. I give you 2 examples. In one case, the patient had, the probability of mortality increased from actually 4% to about 15, 16% in one day. So then we have a red flag. The patient became red, and during this first day that this happened, they looked at him closely and they found he had a surgery 2 days before, and internally there was a local infection that was starting to expand. This was not detected by the humans, not to that degree anyway. And of course, they rushed him to emergency surgery. They cleaned the infection, and the patient was saved. Another case was also that the patient did not have an abrupt change, but it went from 2 to 5 to 8 to 12, and the system detected that. 3-4% changes, as I mentioned, are not detectable easily. So what has happened after they do a series of tests, when we flag this in the system, is that the patient was detected with sepsis. Sepsis is a major cause of death in hospitals across the world. At a high-end hospital like Harvard, about 50% of the deaths in the hospital are attributed to sepsis. And after a certain point, if the infection goes in the blood, it's very hard, almost impossible to stop, even with very strong antibiotics. But because we detected it early, the patient was saved. So these are examples of length of stay. Another one is understanding the utilization of the ICU, the internal, the unit that increases the level of care for patients. And we have found that by predicting utilization of the ICU in a better way, we are able to allocate more fairly and more appropriately a very critical resource. So this is continuing. We also, in fact, today in the afternoon, I'm giving a presentation about a deterioration index for patients, which is less than death. Deterioration index if the patient is worsened, but if you can predict it earlier, you might actually avoid this crisis, what's called code blue, that if somebody has code blue, means that they have rapid response teams that run to save the patient. But if you can predict it earlier, even with few minutes of delay, you avoid very difficult things, and we have made good progress on that. So hopefully you have a sense of the application. And another one, or what I call ED nursing, all of this has been implemented in software. It's now running not only in Hartford, I'll tell you where else it's running, in multiple places. But ED nursing optimizes the availability of and deployment of nurses in the emergency department across the board at the Hartford healthcare system. That's a complicated system. It has about several hundreds of people daily coming to the emergency department. And you need to allocate fairly and appropriately the nurses into the various rooms that they have, in the various jobs and so forth. There was not a system that was available before. So currently we appropriately utilize it every 6 weeks. So we re-optimize the system, and it allocates, in addition to which nurse does what job at what time, it also allocates vacation days. It tries to be fair in the allocations so that people have weekends, equal number of weekends, equal number of work days, night shifts, and so forth. So hopefully you get a sense of the use of analytics in a hospital environment. Since we have finished the application to Hartford, we have since used it in another major hospital in the United States, in the University of Massachusetts Memorial Hospital, has about 800 beds. And we have just finished a pilot in India, the Apollo hospitals in India. We have finished the pilot, and we are in the process of implementing this to 72 hospitals in India. So we are also have discussions with many other parts of the world, and we feel quite happy that the implementation of this work had make a difference in the areas that it has been implemented. So another application is what I call holistic AI for medicine. The acronyms stand for HAIM, H-A-I-M, which is a Hebrew word for life. So this is the idea in medicine, as well as many other areas, meteorology and so forth. We have multiple sources of data. We have, in addition to tabular data, in this case, electronic medical records, we also have scans, CT scans, we have X-rays, MRIs, but we also have language reports of doctors and nurses, radiology reports, multiple others. We also have genomic information in some areas, especially in oncology. So overall, we have what I call multimodal data. And what we have developed, we have to develop an architecture called HAIM that utilizes all this data to make better predictions for patients. So let me give you a large collection of applications. So we have using this technology to detect domestic abuse at one of the major hospitals in Boston, the Brigham and Women's Hospital. So domestic abuse is what I learned is actually quite widespread in many areas of the United States as well as around the world. And this is a very strong application of HAIM in that you get data from scans. You see, for example, if there are bruises in the bones, if there are injuries in the bone system. You also have psychological reports from nurses that are experts. You also have blood tests and so forth. And we have developed a system that is capable of predicting domestic abuse with above 90% accuracy. The system is currently in pilot at Brigham and Women's and Mass General Hospital. And we have also made arrangements for the system to be utilized in other 3 areas of the United States, once in the South, once in the Midwest, and once in the West Coast. Similar application is detecting human trafficking. Human trafficking is also widespread. It's even more widespread in outside the United States, in third world countries. But the application is also very appropriate because a combination of language, and these victims, mostly women, do not actually acknowledge that they are being trafficked or they are being abused. So you have to detect that. And what we have developed is a system with reasonably high accuracy. Nothing is perfect, of course. We are able to detect some of these issues. Of course, this also goes in many other areas. For example, I already mentioned deterioration events. I already told you a little bit about it, but now outside of Harvard at the University of Massachusetts Memorial Hospital, we also utilize it for utilizing images and language as well. Predicting edema, if somebody has, for example, a stroke and comes to the hospital, the key question is the person going to develop edema, swelling of the brain in the next 24, 48 hours? Because if you predict that the person is going to have edema, swelling, you have to treat the patient differently. Typical doctors have an 85% accuracy of predicting that. Machines, our method, has more like 95%. It's an improvement. Early detection of cancers, gastric, colon, prostate, breast cancer for women. From MRI, CT scans, lab results, and radiology reports, we have also found that machines are significantly stronger, in about 10% higher, again from 85, low 80s to low 90s accuracy. And you realize this can save a life, because if you detect with higher accuracy a cancer that would not otherwise been detected, a life is saved. Because unfortunately, we don't know how to, many of these cancers, we know how to cure them. But if you can prevent them early and you surgically remove them, the patient can have full recovery. So detection is critical. So another application of this technology is also on meteorology. We have utilized and published a paper recently on detecting hurricanes. With the climate change, it's very clear that the weather phenomena become worse and worse. I come from Greece. In the last 2 weeks, Greece has terrible floods. Almost a third of the country is flooded, very significant floods. People have died, and so forth. Significant economic disasters, but most importantly, loss of life. So if we can predict this weather phenomena, and this weather phenomena, typically we have historical data that involves images, newspaper articles, data, tabular data of of pressure, of temperature, and so forth, atmospheric information. We have found that we can predict hurricanes and significant flooding much more accurately than in the past. So I do believe that the era of AI has arrived, and with the technology being increasingly improving, I believe that there's exciting new applications. Another application, more on the prescriptive side, along the lines of what Dick has been talking, is improving bus routing and selection of times for starting schools in Boston. And most recently, I have formed a company called Alpha Route that currently serves about 20 cities around primarily the United States, but not exclusively. And what we have found, we have a recent application in the southern United States, where our optimization algorithm was able, the previous year, they utilized 905 buses to service the students. However, because of budget cuts, they had to decrease the number of bus drivers to around 600. So that's why they contacted us, and we calculated a solution that daily utilizes about a third less of bus drivers and buses for significant benefits to the economics, that basically is capable of doing the job equally well as the previous solution. So also in other cities, we also help them to decide the times of schools. The reason this is important is that typically the times the schools start is typically decided in the past primarily to favor the most classes from society that have more influence. So as a result, at least in Boston, the most favorable such times were in financially wealthy neighborhoods, and which were typically these affluent neighborhoods are mostly white. But when we did this, the changes and so forth, we have found there was no issue with favoring a particular class. We have actually overall improved the system and the fairness of the system significantly. We have managed to apply this in various areas of the country since then. So, so hopefully you have a sense of improving the routing, the transportation for students, having more equity on the times, improves, of course, the preferences of the people, improves health for children, equity, as well as decreases costs that are invested in education. In fact, in the southern United States city, we saved more than $30 million that was reinvested in education. Another project from the recent past is that, in fact, it's relevant for me today because I currently have COVID myself. But as you know, a couple of years back, there was a rush to develop new vaccines for COVID. This was a novel virus for which we did not have a lot of information, a lot of background. So we have therefore helped Johnson & Johnson, who developed one of the vaccines, we built a model that predicted the growth of the infections around the world. We had a model that our website was used by about 10,000 users a day, and Johnson & Johnson used this model to select where to do its clinical trials. It selected 10 countries we proposed, and in the process, Johnson & Johnson correctly detected. It went to South Africa, for example, and that was where one of the major variants was first observed. It went to Brazil. And this was at the time that nobody was doing clinical trials in Brazil and South Africa. So I think it was reasonably successful, and we have observed that Johnson & Johnson, the division was called Janssen, were able to improve compared to what they were doing before quite significantly. We estimate that over the course, we accelerated the proof that vaccines are effective by several months, hopefully saving thousands of lives in the process. Hopefully you have a sense of the topics. I could go on, but I would like to emphasize something that Dick also mentioned, that in my view, the era of analytics and AI has actually arrived. There is data, significant data in electronic form available, and significant problems, many of which Dick mentioned, I mentioned some also, that we can utilize. It's a matter of our imagination. The techniques are there, and with the evolution of AI being more and more powerful, I expect we'll have more and more great applications in this arena that would be improving our world, as the title of our initiative suggests. If there are any questions or comments, I'll be glad to answer them. I see Hannah has a question.
I think that's the reaction clapping emoji. So they're just giving you a clap. But if anyone has a question, you can raise your hand using the reactions button and then click raise hand.
I see a gentleman, Alvaro.
Thank you. Can you hear me?
Yes, we
Yes, I
can.
Okay. Yeah, I was just curious on some of the examples you were showing. They're based on really analysis done by machines. So what is any burden of proof additional needed? You know, in the case of domestic abusers or other things. I mean, what was the
Very
ability
good.
of users
Very good.
this analysis?
Excellent question. So clearly, these are machines that take all the information and make predictions. We, of course, calibrated and tested before we start using it in practice. We basically utilize them in the lab. We say, this is where we have proof of domestic abuse. The algorithm also said, and we're about 90% accurate, Alvaro. Namely, of course, we are not always perfect, but what we have observed is that in experiments, we're about 9 out of 10 accurate, which is much higher than the radiologist before. So as a result, the hospital has decided to start using it increasingly so.
Thank you.
All right. The next one we have is from Shuala Amida.
Yes, thank you so much. Please, can you hear me?
Yes,
I
we
can.
can.
Where are you
Okay.
talking to us today from?
Okay, I'm talking from Nigeria.
All right. Difficult times there.
Sorry?
Difficult times there, I understand.
Yes, thank you so much. So I'm glad to join this session, and I really appreciate your presentation. Thank you so much for all you're doing. I just want to ask if there are documentations or probably articles that capture all of these projects you have done, where we can read more and probably get more inspired about them.
I mean, some of them are ongoing, some of them completed. I will show you, I will send you, I will put on the chat my website that has all of my papers. I mean, not all of my papers are ABW papers, but there are quite a few of them. So my thinking, the best is to go there. So while we are talking, I will try to put my website in the chat. Just give me 1 minute.
All right, thank you so much.
Okay, that's
Next, I think we had a question from Hannah.
Yeah, I have a question. I'm calling from the US, but I had a question about the medical bias that like how that was accounted for in some of these studies, but I believe that probably should be on the website. So I think that answers my question.
but I would be glad to answer if I can. I mean, about, is there anything in particular bias?
For sure. Yeah, just from a US context, medical racism is just like pretty well documented. And so I was wondering which indicators or how you coded in that possibility when you were studying that.
Well coded, I wouldn't say that, but it's definitely what you call medical racism, namely it is available in the notes. In other words, the notes for nurses, doctors, and medical personnel, this is how they think about the patient. So we detect this from the actual notes, from language. It's not coded in the, at least not in my experience, in the electronic records. But it's very relevant, as you observe, but we detect it in the notes.
Thank you.
And I think we have one last question and then we'll move on. And that's from Ogler.
Thank you. My question is directed to Dick Den Hertog. And thank you both for great presentation. And I'm calling from, I'm based in New York, but I'm currently in Belize. So hello from Belize. Yeah, thank you for a really great presentation. I found the mapping of access to hospitals versus the households was very interesting. And I just had one question on do you incorporate access to roads and quality roads in your calculations, or is it just based on distance from hospitals and households? Because from my experience, not just distance doesn't matter. Also, sometimes there's roads and the roads are located in different places depending on the household. So how would you calculate that?
Yeah, you're completely right. So in fact, using just the distance, the Euclidean distance, as we call it, is not valuable, because maybe also in the pictures that I showed you, sometimes there is a hospital very close, so you might think, you know, it's reachable, but maybe there's a barrier in between and you have to go all the way there. So indeed, we used digital road map information. That's a problem, because especially in many of those low-income countries, that's a big problem. So what we also spent a lot of time on is, for example, combining. So we had in Timor-Leste, we had two road maps, and we spent a lot of time to combine those two. That was not easy, to combine it in two, to get a richer, a better, and higher quality digital roadmap. And in another project, for example, what we also did is we had GPS on trucks, and that the data, the information that they give, the signals, are used to detect roads that were not mapped.
Okay, great. Thank you, everyone. Then again, a big round of applause for both Dick and Demetrius's presentations. And we'll go now to some practical information for the fellowship. And I hope everyone can see my screen. Okay,
Yes.
great. All right, so let's quickly, again, my name is Kate Henry. Prabhati introduced me in the beginning. It's very nice to meet everyone, and we're very excited to work with you guys in the next 8 weeks. As she mentioned, Marta and I are here to support you, and we prepared some different information that hopefully will give you all the information that you need to make this journey as smooth as possible. So I'd like to quickly go through information about the handbook, some information about Slack, GitHub, Zoom, and I want to mention 2 things before I do that. The first is, as mentioned in the introduction email, you'll get a certification at the end of this process if you've attended 80% or more of the sessions. So it'd be very helpful for us when we're taking attendance if when you log into the Zoom that you use your full name. That helps us to make sure that we know who you are, and we have the right people. So if you have a nickname or maybe a shortened abbreviation, just make sure that you also add your full name so that we're aware. Also, some of these sessions are quite short, so you'll notice that some of the sessions are only going to be 1 hour long. And we want to make sure we get the most out of that time. As you saw in the beginning of this session, it can take some time to get everyone into the lobby, from the lobby into the meeting, getting the camera turned on, getting the microphone working. So it'd be very helpful for all of us if you can join 5 minutes before the start of the session so that we can make sure that everyone's present and we can start right on time. All right, then I will go into some more practical information. So you should now be able to see the Slack application. So as you should have already happened, but if not, you can, after today's call, join the Slack channel, specifically under Second Cohort Fellowship. This is where we will post some information so we can communicate within here. You'll notice that we've already added the ABW Fellowship Handbook, and our calendar visual. So this is also a visual of how you can find the different sessions. So if we look at the handbook, at the top, you'll have information about the calendar. So you can also add the Outlook calendar to your Outlook. So then you can easily see it also in your work calendar to make it easier for you. All the sessions are hosted via Zoom. If you have any, if you need to access, the access information is here. So the Zoom meeting ID and the passcode is available. So you can easily log in. Everyone has access to this meeting. So hopefully that's pretty straightforward. And then we have some preparation materials. So before certain sessions, the trainers have asked that you do some preparation activities. So you can see, for example, the GitHub course, making sure that you have a GitHub and you can access the ABW repository. So make sure that all of these pre-work are executed before the training session. Some of them are very short, so it shouldn't take you very long. Others might take a little bit more time. So please scan through it and make sure that you give yourself enough time to complete these before the training so that the training can be as beneficial for you as possible. At the bottom of the handbook, you'll also see that we have our recipe for success. So this was mentioned a little bit already around attendance, but also just wanted to highlight some additional things that can help make sure that this goes as smoothly as possible for you. So make sure that you're in a quiet location. So please try to avoid being on a bus or a train during the sessions because we want it to be something that you can give full focus during the session. As Robert mentioned at the beginning, it's really nice to see everyone's faces. So we don't feel like we're talking to a black box. So great if you can also turn on your cameras during the sessions. That also keeps it interactive for the trainers as well. And as we mentioned, reserve time not only to do the work beforehand, but it's always helpful whenever you take these kinds of programs to also save some time after the sessions occurred to review the material so it can really become embedded and really absorb all of the knowledge that's being shared. We also want to introduce you to the fellows so you can get to know each other and you can also get to know the trainers and mentors. If we go into the Slack, so you'll see within practitioner course and cohort 2. So if you haven't already logged into Slack, created a Slack account, you should have received an invite. Make sure that you join so you can get all of the information. Also, the slides from today will be uploaded as well. So what you'll see in the cohort 2 folder are some subfolders where you'll find, for instance, the launch event. We'll post the slides from today there. You'll also find the fellowship handbook that we were just going through, as well as the presentation of the fellows and the mentors. So this is the full one-pagers that you guys created introducing yourself. So if you'd also like to get to know your fellow fellows, then you can go into here and read those as well. And we also have the same from the mentors and trainers. So it's also an opportunity to get to know everyone, all of the mentors and trainers. And I think I will stop sharing. Oh, my mouse is gone. Sorry. Now it's back. Okay. All right, so that was a quick overview of the handbook, also the Slack channel and GitHub. Zoom, I think hopefully you've gotten some time to get a sense of how it works within here. I want to highlight some of the features that we're going to use during the sessions. So the chat functionality, you can use the chat to send a message to us. During each session, there will be someone in addition to the trainer who's available to read the chats. So they can, if you're not able to speak, maybe your microphone's not working, you can always send a chat message and then the facilitator will read the question to the trainer out loud. Additionally, as we've already had some people use, if you can use the raise hand function, this also helps that we can find a good moment to pause and answer questions. So if you do have a question during the sessions, please raise your hand and then we will call on you to ask your questions. And then lastly, we will be using the breakout rooms during the sessions. So this is a way for the trainers might have some hands-on activities that they'd like you to work on in groups. So that will be something that we'll use during the sessions as well. And we're going to actually practice using the breakout rooms now so everyone feels comfortable during the courses on how they work. So we're going to break you guys out into groups of 5 to 6. And what we'd like you to do is in a round robin. So that just means basically one at a time in a circle. Introduce yourselves to each other, share your name, the organization that you're coming from or that you're working with, where you're based. So that can be physically or in your mind or in your heart. And then also your main goal that you hope to achieve from the fellowship. So this is just an opportunity to get to know each other as well. And for a fun little activity within the group. So we already get some group work. I know everyone loves working in groups. But we'd like you to calculate the total kilometers between all the group members and then share the answer in the main chat. So we can see which group has the most distance between yourselves. And feel free to appoint one of your people in the group as the leader who's going to be responsible for sharing that chat. So we're going to open up the rooms. Bear with us. It does take just a couple seconds to get them open. Britt, do you have a question? Oh, you're on mute.
I have a technical question about the total kilometers. Should we calculate like the traveling salesman distance, or should we do something with the distance matrix?
Yeah, let's leave it up to each group to decide. Maybe that's more fun. All right, give me 1 minute and I'll get the group breakout rooms all set up. We have 87 participants. Okay, so we're going to open up the groups now. We're going to give you guys 10 to 15 minutes to discuss, and then you'll be brought back in. So we'll close the rooms. We'll give you a notification. We're going to close the room. So then you'll come back all together, and then we'll have a question and answer session at the end. Okay, that went smooth. I can't hear you, Marta. I don't know if you're talking to me.
Yeah, there's still some people that are need to join the.
Should I pause the recording?
Yeah.
All right. So then for the leaders of each group, if you could share in the chat the total kilometers, and we can see which group. So maybe the group number and then the total kilometers, then we can see which group had the most kilometers. All right, 30,000 from group 8, 24 from Carlo's group. Group 6 had almost 30. Okay. All right. Wow. So it looks like I think group 8 might be the most. Let's see. Can anyone beat 30K? Oh, we got one. Group Valerie's group. Oh no, Martine's group, 66,000 kilometers. Wow. That's a lot of distance between everyone. Yeah, I think Martine's group. Congratulations, guys.
I think we got a typo though.
Oh, okay. Oh, 51,000 from Brit's group. Very nice. All right. Another 15K. All right, we have a lot of distance. That's really cool to see. All right, before we wrap up and oh, Kevin, did you have a question?
I do indeed, yeah. Just quickly, something we were a little unsure about in our breakout room. If we use the chat functionality in the breakout rooms, is that just for our breakouts, or did everyone see us post our coordinates?
No, that was just within the group. Yeah.
Perfect. Okay, just making sure. Thanks.
Yeah.
Good
Great
to know
question.
for next time. Thank you.
Yeah. But I think what I believe is that you can also send the host a message while you're in the breakout room. So if you need something like during the sessions and you need the trainer to join your breakout room, you can also send a message directly to the host, and then we can call them into that session.
Actually, we tried, but now, for example, I can send a message to everyone, or to Kate or to Marta, but in the group, just send the message to everyone, but we were not sure whether everyone means the group or everyone in the call.
Yeah, that was just within the group, but that's a good question. Yeah, exactly. All right, then before we go to the Q&A, we're gonna take a quick group photo. So I'd ask if everyone could turn their cameras on, and we're gonna look at our cameras for a very awkward period of time because my lovely assistant Marta is gonna do quick screenshots. So if you can just smile and think about data. And she's gonna let us know when she's gotten all the shots. And we have such a great diverse group. So I think it's wonderful that we take a celebratory launch event photo together.
Okay, I think I got it. I had to take a few screenshots, but yeah, we'll see what ends up in if I try to put them all together. But
perfect. So we have happy faces at the launch event. We'll do this again at the closure, and hopefully even more happy faces at the closure, right? All right. I'm going to quickly share my screen one more time, and we're going to open up the floor for any questions that anyone has. Feel free to raise your hand, or you can use the chat function. We already got some great questions. So while you're thinking about your other questions, we're going to go ahead and answer the ones that we've already received in the chat. All right. So the first question, and Parvati, I think you're still in the call, so you can help with the answering as well. So just jump in. The first question was, will we have lab time and group work?
So by lab, if you mean hands-on, yes. So there will be sessions like Python and Power BI where the trainer will be sharing their screen and you code along with them. And if you get stuck or if you have different groups, there will be some interventions, and it totally depends on how the course is structured. So some courses will not have lab work, some will have, and some will have groups divided into groups and the group working together, and some do not. So it's a mix of both. Thanks.
All right. The next question is, will the sessions be recorded? I can quickly answer this one. So yes, all sessions will be recorded. And also related to the next session about the slides. So both the slides and the slides will also be made available to everyone. The slides will be posted in GitHub along with all of the accompanying materials that you guys use during the sessions. And the sessions that are recorded, we're going to be uploading so that you guys will have access to view them later. It does take quite some time to process and to get everything uploaded, so they won't be available the next day, but we will be making sure that everything's available to you by the end of the program. The next question that I see in the chat is it possible to share a calendar link for the Gmail users? Right now we have everything that's through the Outlook. We don't have a Google Calendar, but you can also use the visual that we've created, so you can add those as well to your calendar. I hope that helps as well. Oh, lots more coming in. So let me scroll up. The next question we have, thank you for the great session. I would love to learn more about the knowledge sharing activities in the community practice. Is there anyone in ABW I can reach out to learn more? Parvati, do you want to take that one?
So do you mean specifically for this academy, or in general about the knowledge sharing activities that ABW is doing?
In general, for ABW activities, because the work I do also has that version of it, and I would learn to like what specific activities ABW does and discuss more.
If you can reach out to me either via Slack, LinkedIn, or email, I think you should have my email. I'm also in Slack. We can schedule a call and then, yeah, discuss how best and who to involve.
Great, thanks, Parvati. The next question we have is about the GitHub link. So everyone was emailed the handbook, and you can find the GitHub link within that handbook. So please check your email. If you did not receive the email with the handbook, then please reach out to us via the email that you were accepted to the fellowship with. And we can make sure that if your emails are somehow getting in the junk folder or somewhere else, we can make sure that that gets sorted out. Next question, I understand there's a prep material, but as someone who's fairly new to data science, is there any additional prep I should do, or the session's beginner friendly? Parvati, do you want to take that one?
So there is preparation materials, but if you see, most of it is to get you introduced or download some things to set up before you start the session. But most of the sessions are beginner friendly. We have also looked at your applications and kind of made this selection based on kind of demographics who can handle these courses. So yeah, it's very beginner friendly. And I also saw a few questions in Slack about this sent to me during the session. So the cases that were shown today by the professors are just for inspiration. So we are not going to directly jump into optimization use cases or advanced level analytics. We'll go slowly, one step at a time. So most of the initial courses are more basics. Then slowly you learn about machine learning, text, geospatial. So yeah, it's a very beginner friendly curriculum. And as you progress over the 8 weeks, you will be introduced to some complex methods and techniques as well.
Great. Thanks, Parvati. The next is the GitHub link in Slack is showing a 404 error. Is that due to accessing the ABW GitHub yet? Yes. So the GitHub is restricted only for those participating in the program. So it's important that you log in with your GitHub account that's been invited. If you're having any access issues, you can reach out to us on Slack and we can make sure that you have access. But that's why you're receiving that 404 error. That's because you need to log in before you click the link.
Sorry, can I also, with the GitHub, we're having some we just need some time to send all the invitations to everybody, because there's a time limit for how many invitations we can send every day. So you will get it before the end of the week, you will get your invitation. And if not, again, you can reach out and we can try to figure it out.
Thanks, Marta. Next question. I'm not sure if everyone is having this issue, but I'm not able to access the Google Colab link or the GitHub link on the handbook. I think this is also related to logging in, but Prabhati, do you have any specifics on the Google Colab that you want to add?
I do not exactly know which link do you mean. Is it to download? Like, for example, Google Colab link, I have just pasted in the chat. So this should take you to the Colab. GitHub, we already addressed that question. So shouldn't be a problem. Once you have clicked on the link in your email, which Martha is setting up, you should be taken to ABW GitHub. So yeah, you then create an account using either your official or your personal GitHub ID.
Great. Then the next question we have is about being able to download the handbook. Yes, so the email that you all received, there's an attachment, so you should just be able to download that attachment directly to your laptop. If you're having any issues, you can reach out to us via Slack, and we can see what the specific situation is. The next question, will we have guidance on how to handle sensitive data? Prabhati, do you want to take that one?
Yes, so I would say in the course there is a session on this as well. In addition, if for example for your project you are using sensitive data, then the mentor will of course sign an NDA on an individual basis, but we need to discuss what are the terms of the NDA so that the mentor can, for example, look at the data. But also for the project work, you do not really have to give access to anyone. You do the analysis on your own in your preferred environment, and you can then ask the mentors for support more on the implementation side. So yes, you will learn how to handle sensitive data, and for the project, if you have to work with sensitive data, we will take into consideration that and make the best possible modality for that. Thanks.
Great. Thanks, Prabhati. The next question is about setting up the tools, which are not supposed to, how about setting up tools which are not supposed to Mac OS, such as Power BI and SQL? Do you want to answer that one, Prabhati?
Yeah, so all the tools, Power BI and SQL, work in Mac OS as well. But I did see this message in Slack, and I have already reached out to the trainer. I think this is for SQL. For Power BI, there shouldn't be a problem, but the SQL pre-worksheet only shows the steps to download it in Windows, not in Mac. So yeah, that will be updated, and I will give you an update in Slack, because it is possible to download the same SQL manager in Mac as well, but we didn't provide the information about it to you yet. So we will update, and I will send a message in Slack to take a look at it.
Yep, and to follow up on that, there was a question about the list of software. Again, that's all outlined in the handbook, so please just read the handbook, and if you've done all the preparation activities, then you will have everything that you need for the fellowship. The next question, is it an individual project presentation for the fellowship or as a group? Regarding to the project, is it a group assignment or a personal one? So the question, Prabhati, is about the project presentation being individual or as a group.
Yeah, sorry, it was my son, so I got a bit distracted, but I heard the question. So it is an individual project. So each of you will have to pick a use case from your organization and work on it individually. But you will be given a peer review feedback, and you can have a discussion more on, yeah, is it, do they have ideas on data or on tools, techniques? So the peer review group is just to support you, but everybody will do the project on their own.
Great, thanks. The next question, are we also going to look at open source solutions other than Power BI? Prabhati, would you like to answer that one?
Yeah, so if you look at visualization, we do have Python course. So Python 1 covers basic like structured data visualization with Python. Then we have Python 3, I think, 2, which is on geospatial data visualization. which is also with Python. So we will cover visualization using Python, and then we'll also learn how to use Power BI. Now, Power BI is just to be considered as a tool. So it will help you understand best practices and how to get familiarized with Power BI. But the same kind of skill sets and knowledge can be applied. For example, if you are using ClickSense or Tableau in your organization. So it's kind of transferable skills which you will learn in that course.
Great, thanks. The next question is about accessing recording sessions. So yeah, again, we will be sharing the links to all of the recordings at the end. Because it takes quite some time to upload, we can't guarantee that they'll be available right after the session, but we'll do our best to get them to you as soon as we possibly can, and you'll receive the links so that you can watch the recordings. The next question is regarding to any scholarships available for the master programs offered at the University of Amsterdam. We do work with the University of Amsterdam, but we don't directly work with the master's program. So I would suggest that you look at the University of Amsterdam website for all of the available resources that can direct you towards what's available for you out there. We don't have expertise in that area, so unfortunately we can't answer that very well. The next question is about accessing the documentation for the projects that were implemented by the first cohort. So I'll let Prabhati answer this one.
Yeah, so once you go to GitHub, the repo that was shared with you, there are two folders. One is cohort 1 and cohort 2. So under cohort 1, you will see a list of projects that last year the fellows did. You do not see their implementation. Some of them have uploaded code because they work with open data, but you will see like a project description, what data they used, what were the outputs. But no sensitive information like the data or the results or conclusions are there. So it can be used as an inspiration for your projects as well.
Great. Thanks, Prabhati. Do we have any additional questions? All right, then we will conclude. We look forward to seeing you guys on the first session next week. If you do have questions that come up in the meantime, you can message us on Slack. We'll be checking that so we can give you updated information. I'll hang out a couple more minutes. So if you have any specific personal information, you can stay on the call. Marta, Prabhati, and I will be here to take on a one-to-one basis. But otherwise, then I let you guys go on with the rest of your day. And I hope you have an amazing Wednesday. Thanks, everyone.
Thank you.
Thanks a lot. Bye-bye.
Thanks so much.
Thank you. Take care. Bye-bye.
Thank you.
Thank you, everybody.
Thank you and bye.
Thank you, everyone. Bye.
Bye.
Thank you. Thank you for all. Bye.
Thank you so much. Bye.
Thank you.
Bye-bye. Thank you.